Hello everyone, today we'll be discussing soft and hard nucleophiles or bases. So before we proceed, let us consider the definitions of soft and hard nucleophiles and bases. So by definition, hard nucleophiles and bases, they are those species or molecules in which the lone pair or charge are localized on the atom and they are not polarizable. Examples are, we have the hydroxyl ion, we have the sodium hydride, we have the alkyl lithium, we have the fluoride ion, we have the general representation of the alkyl lithium, and the last we have is the Grignard reagent. So important thing we have to consider is that most of these hard nucleophiles, they are Lewis bases, and by definition of Lewis bases are defined as electron pair donor molecules. On the other hand, soft nucleophiles, they have their lone pair either delocalized or in a large orbital. So, having the knowledge of soft base and nucleophile and hard base or nucleophile will enable us to predict the chemoselectivity of a nucleophile or base reaction in a chemical reaction. So here, what actually differentiates the soft or hard nucleophile from others is that in soft nucleophile, they are characterized by large orbitals, and their lone pairs are actually delocalized in the molecule, unlike the hard base that it is actually localized on the molecule. So with this now, in a reaction with a nucleophile or an acid, we can actually predict the chemoselectivity of the reaction. So let us consider some worked examples. In this example, we have the acetone reacting with both hard nucleophile and soft nucleophile. The hard nucleophile actually replaces hydrogen in the reaction, whereas the soft nucleophile does not replace hydrogen in the reaction. Rather, it actually reacted with the pi bond in the molecule. The soft nucleophile will react in the less acidic side, and the less acidic side is the CO double bond is the less acidic side. This is where the soft nucleophile will attack, while the hard nucleophile will react in the more acidic side. The more acidic side is the site where we have the acidic hydrogen. So this is the point the hard nucleophile will react. Having the knowledge of the less acidic side and more acidic side is very, very beneficial. Another way to figure out exactly why the CO double bond is regarded as the less acidic side and why the CH bond is regarded as the most acidic side is having a full knowledge of the orbital energy level. So I'm going to represent the orbital energy level. From there, we can actually explain why the CO double bond is considered as the less acidic site. This is the order of energy level in increasing order. From here, we note the increase in energy level. This is pi, this is pi star, and this is sigma star. For a bond to break, it actually means that electron has to be donated into the pi star or the sigma star. From here, we observe that to break a bond, which is the pi star, is lower in energy than to break a bond, which is the sigma star. Meaning that the sigma star is of higher energy than the pi star. So hard nucleophile tends to break the sigma star, which is high in energy, than the soft nucleophile that tends to break the pi star. Let us consider another example using this alpha beta unsaturated carbonyl. We have two sites the nucleophile can either attack. The nucleophile can either attack in this position 1 or position 2. So we have two acidic sites, position 1 and position 2. So these are the two possible sites the nucleophile can attack. But the main question is, where will the soft nucleophile attack and where will the hard nucleophile attack? This will lead us to the nature of bond. The nature of bond will differentiate where the soft nucleophile will attack and where the hard nucleophile will attack. Soft nucleophile usually attack in a place that has a less stronger bond, while the hard nucleophile will attack in a place where the bond is quite stronger. So from this example, we can see that the CO double bond is stronger than the CC double bond. So for this reason, the hard nucleophile will attack in a region that forms a more stronger bond, which is the CO double bond. The CO double bond is regarded as the more reactive side because the CO double bond is stronger, while the C double bond is regarded as the less reactive side, and that is the place where the soft nucleophile will attack. So why do we consider CO bond to be stronger than CC double bond? And also, why do we consider the CO double bond to be more reactive site than the CC double bond? The CO double bond is considered stronger than CC double bond because the CO double bond is covalent and partly ionic because of the difference in electronegativity between the carbon and the oxygen. But the CC double bond is purely covalent. So that is why the CC double bond is regarded as the less reactive site where the nucleophile will attack, and the CO double bond is regarded as the most or more reactive site where the hard nucleophile will attack. This will take us to an important subheading known as kinetic effect. In the kinetic effect determines which reaction occurs faster. So in the first example of the kinetic effect, where you have the hard base reacting with the hard acid, the reaction is usually very, very fast. In the second reaction, we have the strong nucleophile reacting with the weak electrophile. In a situation whereby you have the strong nucleophile reacting with the weak electrophile, the reaction is usually very, very slow. So generally, when you have a soft nucleophile reacting with a soft electrophile, the reaction is usually faster. So this explains the general term of kinetic effect. Which product forms faster? Is it when you have a strong nucleophile and a weak electrophile? Or is it when you have a weak nucleophile and a weak nucleophile? So this kinetic effect explains how fast the product will form. When you have a hard base and a strong acid, the reaction is usually faster. When you have a strong nucleophile and a weak electrophile, the reaction is usually slower. Invariably, when you have a soft nucleophile and a soft electrophile, the reaction is usually faster. Please, if you like my video, like, subscribe and share. Then if you have any question regarding to what you have watched so far, I would like to see your questions in the comment section. Thank you.